Okay, hello again. Now we are going to talk about axis. And let's kind of define what that is. And I'm going to take you to the next page of this thing. And you can see here is a depiction of a heart, and a little coordinate system has been drawn upon it. And this is 0 degrees, 90 degrees, 180 degrees, negative 90 degrees, back to 0 degrees. And what axis means is where is most of the electricity of the heart pointing, right? We know that as it depolarizes, if you were to average it all together, and we're really only going to look at the QRS because we're looking at the ventricular depolarizations, where is it most pointing toward? What does this mean? Why would you want to do that? It kind of tells you where is most of the muscle of the heart. Because if there is a lot of extra muscle in one area, it's going to point towards that. What if there's an area where muscle is lost, maybe because of a heart attack, the muscle died? It's going to point away from there. And so look at this picture of a heart that's drawn here, right? So we have a heart here, and we can see that most of it, if I were to draw a picture, I'd say, it's probably there. That's probably the direction that it's in. And that's probably about 45 degrees, I would say. And we want to look at this and try to determine the axis. And let's label the different kinds of axis you can get here. So if you were to take most people, an average, the average of most people's heart's axis is going to fall in this range here, all the way from 90 to negative 30. And so we call that normal axis, because that's where most people normally are. Now, there are some people whose left side of the heart, for some reason, is bigger. Maybe they have high blood pressure. Their body has to pump that heart against the high blood pressure, so the muscle gets bigger. And so the left side of the heart gets bigger, and so it points more toward the left, and so we call this left axis. Now, I know I'm drawing on the right side of your screen. Remember, you're looking at a patient, so it's the patient's left. What if the right side, for some reason, is bigger? And there's some reasons why that could happen. And then that's going to be called right axis. And that would happen when you have 90 to 180 degrees. And very rarely will you see this one where it's actually kind of pointing in the opposite direction, right? And that we would call extreme axis or extreme right axis. It can happen in some rare cases, but we're rarely going to see that. So we want to determine is the patient's heart mostly pointing where most people normally are? Is it to the left of where most people normally are, or to the right of where most people normally are? And so to understand axis, we really want to think about the leads. We need to revisit that again. So I've drawn a picture of a heart here, and we're going to draw that circle around it, and then let's position the leads about where they look to the heart. So the first one we'll put is AVF, and AVF stands for augmented vector foot, because it's looking from the foot, and it looks over there. Lead 1 tends to look from over here. So if we were to draw these as axes, then we'd kind of draw this one up like that, and this one kind of goes across like that. Actually, I'm going to take it all the way to the other side, like that. And now let's draw the other ones. We know that 2 is somewhere over here, 3 is somewhere over here, and AVL, I'm just going to put an L there, and AVR was something like that. Okay, and now what we've created is a Cartesian coordinate system. And so, but it's kind of upside down from the normal ones that you would see. Because what we have here is positive AVF is going to be over here, which means that negative AVF is going to be up here. And we have that positive 1 is over here, which means that negative 1 is over here. Okay, so I drew in 2 and L as well. And so I'm going to kind of color these in, because I know that this is where normal is. I'm going to make that green so it matches the other one. And so now I've drawn it like this. And let's actually just copy this and take this over to one of our EKGs. Okay, so now the leads that we said we're going to really pay attention to are 1 and F, right? So let's do that. So this is 1 and this is F. So we can see here that 1 is pretty much mostly positive and F is mostly positive. And so if 1 is mostly positive here in this direction, and if 1 is positive and F is positive, that puts us in this quadrant here, in the normal quadrant, right? Great. Now, if if 1 was negative and F was positive, that would put us in the right quadrant. And if 1 was negative and F was negative, we'd be in the extreme quadrant. Now, what if 1 is positive and F is negative? Then we're in this one here where it could be left or it could be normal. How do you tell the difference? Well, this line here is the line of difference here. So there's two things you can do. You could either look at L, AVL, and see if it is neither positive nor negative, meaning it is equally positive and negative. Or you could look at 2. If 2 is positive, you know that you're going in this direction and you're on this side of L. You're on the positive side of L, which means it's in the normal thing. If 2 is some negative, it's on that side, and that means you are on the opposite side, the negative 2 side, so it's probably left. And so let's take this, for example. Let's say that this is what 2 looked like. You could see here that there's a little bit of upward deflection, but mostly negative deflection there, right? So that's what one that would be mostly negative looks like. This one is also mostly negative. Here, this one is mostly positive. This one here, it goes up and down about the same. And so you might say that this one is isoelectric. It is neither negative nor positive. In total, it adds up to about 0. And so that's how you determine axis. That's the quick and easy way. You look at 1 and you look at F. And if you're in this little area here, then you need to look at lead 2. And that's what I tried to draw over here. Again, we have our 4 quadrants. This is AVF. This is going to be 1, and now this is positive 2. And so if we have 1 and F being negative, then we know we're in this extreme axis quadrant. If we have negative 1 and positive F, we're down here in the right axis. If we have 1 and F being positive, we're in this green one here that is normal axis. And if we are up in this one where 1 and is positive and F is negative, then it can be either left or normal. And we have to look at 2. And if 2 is mostly positive, then we know we're on the green side. And if 2 is mostly negative, then we know we're on the red side, left axis. So why don't you look at the 3 EKGs that we have and see if you can tell what the axis is. Okay, thank you very much. Bye.